because enthalpies are state function, because temperature is a state function, and because entropies are state functions, then therefore free energies of reaction are state functions as well. So you can just calculate a free energy of reaction by summing up the free energy change of the products minus the free energy change of the reactants. An important thing to note here is that delta G needs to be used tabulated at a specific temperature, right? Because it's very temperature dependent. Unlike delta H and delta S, which are a little bit temperature dependent, but not that much. So it's often simpler to just calculate from tabulated delta H and delta S's. And that's what's generally done. Generally, you don't tabulate delta G's that much. You tabulate delta H's and delta S's, which are a little bit temperature dependent, but not very much. So it's usually a good approximation. So let's see. Let's calculate the Gibbs free energy of sort of a reduction of iron oxide plus 3 molecules of carbon monoxide to make pure iron plus 3 CO2. Okay, so what do we need to do to calculate the Gibbs free energy of reaction? Well, first, we're going to have to calculate the enthalpy of reaction. So let's start there. So the enthalpy of reaction is going to be delta H reaction is going to be the sum of the enthalpy of the products. So products are CO2 and iron. So we have 3 times minus 393.5. I'll leave out the kilojoules per mole. All of these are in kilojoules per mole. Plus 2 times 0 minus, okay, so we have the enthalpy of iron oxide minus 824 plus 2. And then we have plus 3 times carbon monoxide minus 110.5. So we add that up, we get minus 24.8. That's a kilojoule per mole. So we got a lot of big numbers going back and forth. It just barely balances out. This is a slightly exothermic reaction. Now we need to calculate delta S of reaction. And so that is 3 times, going to be the same stoichiometric coefficients because we're looking at products versus reactants. 213.6 is the enthalpy, the entropy change, the standard state entropy of carbon monoxide, plus 2 times 27.3. That's for iron. It's not 0 this time because it's an enthalpy. And these all numbers are on joules per mole Kelvin. 87.4 is the entropy of iron oxide plus 3 times 197.6. That's the entropy of carbon monoxide. Again, it's slightly less than the entropy of carbon dioxide. It's a slightly less complex gas. And that ends up being 15.2 joules per mole Kelvin. Okay, so we can calculate our delta G of reaction is going to be our delta H of reaction minus T, delta S of reaction. And so we get minus 24.8 plus, let's make the units explicit now, minus 28.4 kilojoules per mole, 25 degrees C, so 298 Kelvin times, and now we have to convert this into kilojoules, 52 kilojoules per mole Kelvin. The Kelvins cancel, and we get minus 29.3 kilojoules per mole. So it's a spontaneous reaction. Okay, so that's generally how one calculates Gibbs free energies given entropies and enthalpies.